Start recording. Hello, hello, hello. So this part of the lecture is not going to be a regular expression. It's going to be on something completely different. So have you ever wondered if you sound like an idiot when you talk about Python and what you do in Python, or more importantly, when you try to show your project to other people? It's like, look at this, and then there's some kind of Python scripts, and it's not really professional, and he's looking at other people doing open source project, and it's like, oh my god, they have everything. So I'm not going to show my own projects because my own project sucks. No. Actually, let's do that. I'm gonna live dangerous, because despite the fact that all my typos from my inability to write English at all, I still did a lot of work on trying to get everything to look kind of okay with this type of thing. So this is one of my open source projects, which is a side project from what I did during my PhD. Kind of just made repo and put everything in there, some documentation and everything that's going on, which is not that difficult. You guys knows how to do this. It's not that complicated. But for example, I have this thing, chaospy read the doc.io, which I could just click on, and it's my documentation. And I could have written that manually, but I didn't. I automatically built that as part of my repository setup. And if I kind of go back, and I'm going to show you something that I really should not be showing you, which is part of my job. This is my client stuff. We have a lot of pull requests. This is the page I usually always go to, because that's where we always start. We have kind of type of, we have a little fun. Kind of try to kind of put in some humor there. But the thing is that if you kind of look downwards here, we have these type of colored parts that has like all checks have passed, and as I look here, oh, I have circle CI, a continuous integration. We have code coverage. Code coverage. What's code coverage? Have you seen? Is anybody familiar with code coverage? Like, no. So if you go a little bit up here, you see this little note here. 2 days ago, a little bot went into my site and just made a post and said, hey, you're merging 467 into dev, which increased my code coverage with 0.17%. The diff coverage is 19.9, and it gives me a full kind of coverage report. For example, the hits is typically line by line for kind of the project you do. The misses is which one does my test cover, what does my test not cover. So in a sense, code coverage is a little bit of a module that is plugged into your testing system that just verifies is every line actually run during your tests. And if every line in your code is run or flagged not to care, then you get 100% coverage. And this little thing here just say, hey, this is what's going on with this. This is the change report from one code coverage to another. And if I kind of click on this, you can have a lot of cool little things that comes with it, which includes like, hey, this is the part that is being affected. Green means I'm doing better. Red means I'm doing worse. And you can get kind of, this is actually a good place to kind of go to kind of, if you have some kind of projects, actually do this. If you do any type of collaborations, to just see how well you're doing on the testing world. So here's the trend of how coverage has gone slowly upwards. So here we are at 90 point something, and we started at 75 in before summer. So pretty good. So when you start doing coverage and thinking coverage, it makes the world a little better. And you get these type of graphs where you just like, where's my weak points? And you can just click yourself through and then find which part of your code is the part that has the worst coverage. So really, really nice tool. So this is part of the things that I'm going to talk about now. And there's a million things that can go wrong, but we're going to give it a try anyway. So first, go through the things that you're obviously familiar with. We're going to make a repository. Start a project. I'm going to call it Awesome, because why not? Awesome. I'm going to call it the template. And the reason for that is you guys can download these things and just copy everything I do here. And I'm going to copy myself, because I don't remember everything that I need to be doing, but I have stuff that we can do. I'm going to say that this is going to be a Python project, obviously, and I'm going to say it's BSD license, which just means that do what the hell you like with my code. It's better than GPL from the point of view that you don't really need to keep within the GPL. As in GPL means that if you copy my code, then you have to publish your code. This BSD means if you copy my code, do whatever you like, including making commercialized products. Cool. I'm making my awesome. So we could use the git init. I don't know if you learned the git init at the beginning of this semester, but I never use git init. Why would you ever use git init? How often do you do these type of things? Is not really that often. So typically using it from the website is more than enough. I have a folder for all my git stuff, and I say git clone git at github.com : Jonathan THF. Awesome. Obviously, I've set up my keys, so it doesn't prompt me for any type of username and password. And now I can just go into awesome, and cool, I'm started with my project. Now, you guys were asked to do setup tools, but never ever taught how to do it. So despite the fact that this is already in the past, I'm going to do it again. So just for good measure, I'm going to make a source directory. In the source directory, I'm going to make a new directory and call it awesome. The reason for that is that we're going to make a lot of different folders here. So in awesome, we're going to make two files, init and content. So that's my project. So my project starts in source and points, and the module itself is awesome. Now I want to be able to import that thing. So we make a setup .py, and I'm going to cheat a little bit, and I'm going to borrow from my open source project. So please ignore the fact that this is a little bit fuller, but it's pretty easy. You make setup tools, import setup, and this little nifty little thing called find packages, for those who are not familiar with it. And then what do we need? We need a name. Awesome, because it's all awesome. I'm going to give it a version, 0.0.1. And we don't really need that much. We need these two. These are the important parts. This is the part which I imagine a few of you guys struggle a little bit. You have to define your packages, and you then need to define your package directory. So this one just says, in the folder source, find anything that looks like an init file. That's my package. So you don't need to explicitly define where your packages are. And package just there says that anytime I do anything, that it's from source. So be in source when you do stuff. So import stuff, you are in source. So those two are the ones that are required. That's it. Now, before I actually install this thing, and this is just things that you should be doing, virtual environments. Are people familiar with virtual environments? Not that much. So as a Python 3, you have something called virtual env, when you can say, I want Python 3.6, and I want to put all my executables into Py 3.6. That's the last name there is just a folder that it will be creating. And I like to just say the version of the Python there because A, it becomes obvious what it is, and B, if I have multiple versions of Python, then I can have multiple folders referring to different parts. And then it creates a copy from user local, puts it in there, strips it out, so there's nothing in there. And if I say LA, now I have a new folder called .py_r6, and then I can say source.py_r36 bin, and then activate, and my kind of terminal, my bash prompt, has a little cool feature where it pumps up and say, hey, I am now in a virtual environment called .py36, and I can do something like deactivate to get out of again. But we can do a lot cooler. So we're going to go into a page called auto, and this is not really important for anything, but it's awesome. So if it's awesome, we click onto it. And people who make this are really, really awesome. The reason for that is that they have fun. So going down here is like, how does their project work? You put some kind of string into a file called .env, and each time you do a cd and that file is there, or in any folder below it, it will execute that line. Now this only works on Linux and Mac, so screw you Windows people. You guys are still stuck with the virtual env and doing that manually, but hey, we can automate the process of virtual environments using autoenv. The installation is pretty easy. You just do kind of pip install autoenv, and then you add activate sh in your bash rc. So if I do, I have a few things in my bash rc, but if you're going to go towards the end, I try to use my same thing over multiple systems. So the top part is for Mac, and the lower part is for Linux. So basically, which activate? It's all you need actually, but I am just covering my bases so I can do this multiple times. Okay, cool. I have activate part. I've installed it. Let's assume that you guys are doing the same thing. And then I say v.env, and in env I say source, and then we're going to say home directory git. I'm going to do. It's important to do the absolute path on this, because if you are in a subdirectory, it's still going to do the relative part from the location you're at, and in subdirectory there will be no .py directory. But if I do like this and say activate, now there's an important part. If I go down to my root directory, to my home directory, and look at my, I have an env file there as well. And in that env file, I do a couple of things here, but this part here is the part that I put in my root file. So the idea is that when virtualenv runs, it starts in your kind of home directory, or it starts in your root directory, and then works its way upwards. And each time it finds a .env file, it runs that. So it will first say, hey, if my virtual environment is something, deactivate. Which means that in case in any type of CD will turn off my virtual environment. But in my local .env here, which is in the source directory of my project, I have source.git, awesome, etc., and I activate it again. Which means if I now do cd dot, first of all, it will prompt me and say, hey, this is new, I haven't seen this before, is it okay that I run, in case somebody tries to screw you over and put in their own .env file while you're not looking. Yes, now I am in py3.6. ... I'm outside of 3.6. Awesome. I'm inside Python 3.6. So I can make a virtual environment for every folder that I'm in or want to work with. So make a project, make a virtual environment, make it autoenv such that each time you go into the folder you want to work at, suddenly you're in the environment, the closed environment that you want to work with. Cool. So now we have our virtual environment. So we can say setup.py install, and hey, awesome, gets installed. That's all there is to it from that part. And since I'm in kind of local mode, this is not installed system-wide. I can delete that little directory and it's gone forever, which is really nice. And I can do stuff like Python, run command, import awesome, and then exit. Like that, and it works fine. It doesn't crash because awesome are now available in path. I can be anywhere in that directory or any subdirectory, and I will always have access to it. Now, you can do a little better than the Python install part. You can do another thing. You can say develop. And develop is the part that you actually should be using, you guys. And don't use install. Install is for users. Develop is for developers. And developer does something very similar to install. Instead of copying your kind of kind of Python files and put that into your Python directory and site, yeah. Anyway, inside the Python kind of paths, it creates soft links. So it points back into your repo or wherever you have your Python files. So you can't move them, but you can't really move a virtual environment directory anyway. But now that if you make a change in one of your files, it will automatically be reflected, which means that you can run develop once, and then suddenly you have access to it for forever. Because every time you make a change, it's a soft link, the file is actually changed, and when you do it from Python, you will see that. So let's take a look at that in practice. Let's go into content. Let's make some content here and say def, it doesn't really matter, HTML print, and you say arg, and then we say something like print, and I'm going to just do something really stupid. I'm going to say arg. This is I don't know if you're familiar with the F notation. Has anybody seen this type of notation before? A few. Okay, right. So this is a Python 3.6 invention. So you can't do this on 3.5 and lower at all. What it does, and I really like the style of this thing, is that this is equivalent to doing something in the direction of dot format and then vars, something like that. So vars just takes all your variable space and then put it into dictionary. Formats just take that dictionary and then puts them out. So you shouldn't really be doing that, but it's really nice. And the thing is, though, and this is really weird from a CPython point of view, this is the most kind of the fastest way of doing interpolation in Python. As in, if you do the old style interpolation or the format interpolation, there's functions involved. This is actually put straight into the syntax tree. So the content of strings is now part of your kind of something that's being parsed. This is an expression. It's just happened to have quotes around them, which is very bash-esque, I think, in the sense that strings does not prevent you from having executables inside your strings. But you get this compact code, which is really, really nice. Okay, I made the change to this part. Now, in my init files, I will use, I don't know if you're familiar with the notation, import. Oh, yeah, that's why. It didn't understand. Import HTML print. So the dot in front of my content, has people seen that before? Yes, well, ish. Okay, so when you make a module, use that notation. It works in Python 2, 3, everything. And it's a good way of just saying that, hey, I don't want to have something global. I want to take something from my local space. So this, the dot, one dot means same folder, double dot means the folder below. I'm not actually sure if you can go lower than that, but obviously you can move upwards, so you can go down and up, and yeah, kind of cool. Now, this should be available. So if I now say Python kind of, well, import awesome works, but I can say something like from awesome import HTML print. Now that works fine, because I didn't need to reinstall, because the develop package is soft links to my actual files, and it's available there from day one. Cool. Now, git add init content. Git add setup, and okay, I'm going to use a lot of short keys, but first time git, and then you say CMA. CMA stay for git, and then it's checkout B. There we go. Checkout and base. So that would be git checkout base and then new name. Never work directly on your master. Create a new branch. So this is me creating a new branch and calling it dev. Cool. Then CMA is git commit -all message adding initial files and installer, like this. And now I can do git log, but I have a kind of shortcut for that as well, which basically says that, hey, my master is my root, my initial commit, and then adding initial files and installer is now my development. Now, you could just do a git merge from master, but you really shouldn't be doing that, especially if you're working with other people. You should keep your master sacred. So what you should be doing is you go to your awesome repository, and well, first of all, I need to push dev to upstream. So git push set upstream origin dev, something like that, and then it pushes that up. And now I have two, and hey, look, it says less than a minute ago I made a dev push and compare and pull requests. That's the way to do it. Have you done pull requests? Nobody's done pull requests before. So typically this is a way of telling other people that, hey, I want to make a change. So typically it will take contents from your commit messages to making initial guess at what the hell are you trying to describe. This will be my pull request number 1, and then say, hey, this is my pull request. Now, In this case, I'm trying to go from dev to master, which master is my protected part, which everybody uses. So I want other people to see my code, to do peer reviewing. This is the proper way of doing peer reviewing in real life. And typically you will get something like this. I will give a description to what's going on here. You can look at my commits, and you can look at the file changes, and it will give you the content with pluses and minuses, just like a Git diff. And just, hey, overview, what's going on? Now, I'm the only one here, so I can do the fun thing and just saying merge request. And I can do that. That's fine for now, but you really shouldn't be. Now, okay, getting back to kind of this world, I did a merge here, so I'm going to do a checkout, git checkout of master, and then I'm going to say git pull, and there we go. My git log with graph. Now it shows me a little thing. This is a little nice thing, is that this is my initial, this is where the dev is, and look here, master now kind of is inheriting both from dev and initial because I merged it in. And that's how my history looks like. And that's how you want your history to look like. This type of thing is that you make a topic branch, any type of branch that is not your master or dev or whatever you call it, and then you make some commits, and then you make somebody look at it, and then somebody approves it, and you get merged in. So you get this type of moving in, and you get this linear history. The problem is that sometimes your history kind of master might move along ahead of your time. So you can do kind of stuff to pretend like you're on top of things. So I'm going to do a really advanced thing, which just so you have seen it, is that I can do something called a rebase. A rebase is similar to a merge, but instead of kind of just merging into a kind of common node, you take all your node in your tree and then you move them on top of whatever you're rebasing on top of. So in this case, I'm doing a git rebase against master, which means that, sorry about that. Oh, come on. So I need to just turn this thing off. There we go. Rebase master means moving your developer branch upwards. But before we do that, let's give it some content to just get a feel of what's going on here. So first thing I want to do is to add some tests. And we can do that the way we did the last time. We say that this is an awesome print function. We give it a kind of content, and then we say example usage. I give it that title, and then we say normal usage, and then I do something like print 1, 2, 3. And if you remember from last time, I can then do actually, we're going to do this properly. We're going to do this using pip. Now you're using PyTest. You guys are familiar with PyTest, right? So let's do this with PyTest. So first of all, we're going to do requirements.text. I'm going to fill that up, and I'm going to see PyTest. I'm going to add in PyTest now. And then pip install -r requirements. There we go. Pip PyTest is now installed. Now PyTest does cover doctest, but not by default. So I'm going to introduce you to the setup.cfg, and I don't remember that on top of my head, so I'm going to cheat again. This is your configuration file. Your configuration file, setup.cfg, is actually a place where you can put a hell of a lot of content. So you can do configuration of most things that are Python. So that's really nice. But for what we're doing here, I'm going to do this one, which is really nice. Title, this is a tool for PyTest, and the one I care about is this one. Add option, doctest modules, which means that I'm enabling doctests. Because I made a doctest, I want PyTest to work with doctest. I'm just adding that to my CFG. So let's try that. PyTest source. Cool, it works. Like that. And we can do this again. If I do something like this, there we go. I have short commands for doing this type of stuff. It prints out. So what went wrong? Well, obviously, .html print. I'm doing the wrong function. So run again. Here we go. That's what the one I was looking for. I'm encapsulating my string inside p and p because now it's HTML. Very cool, right? No. Okay. So now that my test works, I can just run it again, and it passes. So that's really nice. The thing I just need to do is just pytest, for example, my file. Well, not, yeah, source, awesome content. Like that, and now it works. And that's because of the options that I said add options. So each time I want to do something all the time, put it into your configuration, and it will do things for you. Many ways of doing that. Cool. Commit. No. Okay. Git add requirements file. What else did we add? Was that it? Yeah. Git add setup. Like that. Commits all. Adding a message. Again. Git commit -a for all. -m for message. Saying adding testing. And then I say git push, shortcuts, and then it pushes upwards. Now look at our history. So this is the thing that happens a lot, in the sense that when many people work on the same projects, master moves ahead of you, and suddenly you have made some changes, and history has kind of moved along. So what you do is you do a git rebase, and then you say, hey, I want to put all my dev commits, or my nodes commits, on top of master. And this is similar to merge in the sense that if there's a conflict, it will say, hey, conflict, now try to resolve it, and you will get very much the same interface. But when you're done, you still have to commit stuff in and then say rebase continue, or abort, or skip in case you don't want to apply a patch. But what happens is it moves the node up on top of master. And if I take a look at it now, it looks like this. So this is the old one, the one that says origin, because I haven't pushed it upstream yet. And this is the new one. This is the new one. And this is exactly the same node. It has a new hash, obviously, because that's how Git works. It verifies. And if it's placed in another place, it's not verified anymore to the same hash. So I can now say git push, and now you have to force it, because now you're rewriting history. So this is the reason why you don't recommend this to beginners, because things can go wrong when you start rewriting history. You should be fairly familiar with Git before or at least you need to think about what you're doing each time you do a -f. Don't use -f if you're unsure. Look it up, because -f can do real damage. You can delete your whole tree, and that's not really good. It happens sometimes. Not talking from experience, obviously. No, I'm Anyway, okay. Back to my pull request. So we're going to do another one. And obviously, it's going to be from dev to master, despite the fact that dev is usually where you start up. And then create a pull request, adding testing. Now we're going to do a cool thing, and that's here. Set up continuous integration. Who here are familiar with continuous integration? A few. So continuous integration is basically, I would compare it to the cloud. It's other people's machines. That's basically what it is. But continuous integration has the nice feature of being programmable from the outside and does things for you which you're too lazy to do yourself all the time. So you set it up once and it runs forever, which is really, really nice. And for open source, most of these tools are free, so it doesn't matter. So if you're going to do commercial and you're going to hide your code because it's not open source, then you have to pay a lot. But we're going to add some continuous integration. I'm going to choose Circle CI. It doesn't really matter which one I choose. This is the one I'm familiar with. And I say add a new plan. And look, if it's open source, it's free. So install it for free. That's cool. I'm billing it to, well, I can bill it to my old company. I shouldn't be doing that. Yeah, right. So I have to, because I've used all my other free ones. Me. Doesn't matter. You guys get, as in you only need to buy it once, in a sense. As soon as you set it up, you can have multiple repository. It's just I needed to show you how this works. So how does this thing work? There's a little bit of a problem in the sense that you need to configure it at first, and there are setups for setting everything up. And you say, hey, I want to do a project, and you say like, hey, where's my project? Me projects. There we go. And then it's like add project. That's how you usually do it. And then I say awesome. There, awesomeness. Set up project. Now, setting up a project doesn't really need you to go into the menu and stuff like that, but it kind of helps because they have this cool thing, and that's a template. And then it's like, hey, you click, this is a Python project. Obviously, you can use this for many type of programming languages. And say, hey, I wanted to be built on something else in Linux. You usually want Linux. But anyway, so I can copy this thing. And let's say we make a folder, which is .circle.ci. I go into circle.ci, and I touch a file called config.yaml. Now, in config.yaml, I now insert my template. Now, we're going to make a little changes to this template. It's version 2. I want to keep the Python version, so when I do Docker, it does a Docker install and say, hey, I want to use Python version 3.6.1. So you can change your Python version here. We're going to call the folder awesome, because obviously we are in awesome. So because we're going to do this multiple times for each time we do a pull request, we wanted to not reinstall every single time. It doesn't matter here because this is just really, really tiny, but if it takes multiple minutes to build, I think my project now takes about 4 minutes to build. You really want to just, hey, use an old one. So it takes a checksum of your requirements file and then say, hey, if that one matches an old one, use that. So you kind of can keep what's going on here. Install dependency, py-m-venv. It just means virtual env. The same thing as that I did with my auto-env setup, and call the folder venv. Then we activate it. This should be familiar. Then pip installed our requirements.txt. This one is also pretty familiar because, hey, I made that file. That's what I did. Now save the catch, and then yep, with the key, the same one as top, in case you want to reuse it later. Cool. Run tests, activate python manage.pip test, which is not something we have. Instead, we can do something like pytest and then source. You can do whatever you want here. This is just commands. Every time you have a command, this is line by line the commands you want to run. We're missing something though. This will not work. I'm not storing artifacts. We need to run something, and that is, indentation. Like that, and then say name install package. So command, multiline, and we need this one. And then Python setup py install. I could say develop, but we're not going to change the content node, so put copy can be just fine. So the steps here are fairly intuitive in the sense that each time you have a run, you give it a name to just say what circle.ci is going to do, and then you give it a command, which is basically a multi-line string. That's what this character here means, just multi-line string, and say what do you want to run. And they are self-contained in the sense that your virtual environment will die between each step. So typically it's kind of smart to split things into steps to see if something goes wrong, you will know where it went wrong. So it will say that, hey, you failed on install package. That's why I'm just doing it this way. In this case, I'm just activating my virtual environment, and then I'm running my installer. And then I can run my pytest. Obviously, this is how I would do it by hand. Therefore, this is how I do it in the circle.ci. So git add config, git add. This is the problematic part. Is this I'm not allowed to do that. Force. Why? Did people get why that was a problem? It says so here. Path was ignored because it's in git ignore. I asked it to ignore Python logic. And Python logic says do not commit YAML files. I don't know why. It just is. So keep that in mind. Right. I've added that file. Anything else? Nope. That should be it. Commit all. Adding circle.ci setup. Push. Git push. I'm using so many shortcut keys. Really sorry about that. Okay, let's see how this works out in practice. We're going back, we're going back, we're going back. This thing hasn't kicked in yet. And the reason for that is, God, GitHub. Awesome, there we go. The reason for that is that the Circle CI only kicks in when you have, oh, I forgot to do this thing, merge. Okay, nope, we're not gonna merge these things. We're gonna, wait, shouldn't this be kicking in right already? Nope, we're gonna merge it. Like that. Then L, check out master. I'm one step behind. Pull. There we go. Check out dev. Rebase master. This is what I do all the time. PS. Push. This a lot of times being used in kind of this type of mode. Okay, CD source. I'm going to add some more content now because I'm one behind. So, if this instance arg is int, raise value error. Wrong format. Now, my test will fail. I've designed it to fail here. I want it to fail because I want to kind of see what happens when things go wrong. So then we say, am I up to date? Yes. Commit all, adding new test. And then I say push. So this will be a normal situation now that Circle CI is up and running. Hopefully. We do a pull request. Create a new pull request. Dev. It pops up. And now, when I say create pull request, add a new test, give it a second. Cool. No, wait. Yeah. Something went wrong. There's always something that can go wrong. Didn't I do Circle CI? Didn't I add you? I am so sorry. Developers. I need to jump into it. Sorry about that. GitHub. Going into somewhere where I have Circle CI. No, I don't. Of course I don't. There we go. Work. So this is how it should be looking, is that I should have these. And why these are not, I would not know. No, sorry, these. There we go. Let's jump into it. Switch to Jonathan. Projects. No. There, projects. Ah, project wasn't added. I forgot to add the project. That's my fault. Sorry about that. Awesome, set up project. So I copied the text, but I forgot to start building. Ugh. Details. Sorry about that. Now it's queued, and then it starts running. You can only run once, one at a time. I'm going to do it like this, and I'm going to remove that so you can see what's going on here. Right now it's just doing your spinning up environment, which it needs to do to start. It shouldn't take too long, but the first time it does. So okay, check out code, restoring cache, installing dependencies. This should look very familiar. Installing packages, running tests. Cool. What happened? Well, it did master, and master is okay. What we've been needing to do is to do something about dev. So I'm going to do git commit and then just say amend, which means that this is basically a git commit, but I'm redoing my last commit. So if this is your oh my god, I forgot something type of thing, which is really nice to have, that it goes back into your last commit, allows you to change it. And you don't even need to do any changes. If you look at the history, it gets a new node. And the reason for that is that Git hashes the timestamp. So if you have a different timestamp, then suddenly it's a new node. So I made no changes, new location, push force. And now we can go back to this project and look what happened. Now that I build the project, Circle CI is now in here, and it starts building again. And look, it failed. Now I'm also getting an email about this each time it fails, so by the time I'm done with this lecture, my email box will be full with my own spam, which is really nice. Anyway, continuous integration. And you can go through and you can see all the steps that I set up: store and catch, install dependencies, install packages, and then it runs the test. And look at what the test failed. It's the one I set up to fail, the wrong format part. So typically we would need to fix that now that we know of it. That you could run, obviously you could do pytest and then say source here, and then it will value wrong format. It will give you the same thing locally. But obviously it's really nice that from somebody reviewing your code that they can just, hey, look at that. The error comes automatically up. You don't need to do anything, and obviously you should be putting yourself in a situation where you don't ask somebody to review code that doesn't pass tests. So nice thing that this is done all the time. Okay, before I fix the problem, also note that something that you should be doing: go into your settings, go into your branches, and then say, hey, protect branches. I want to protect master. And then say, I want to protect it. I want to require pull requests before merging. Also require owner. Is it something you can kind of require yourself? You can require that status checks are going through. For example, you can require that Circle CI has to pass before you're allowed to merge the master. That's the nice thing. That's the thing that if you're going to do a serious project of any kind, or any type of thing that you play around with other people, do that. Save changes. You can also include administrators, but I'm not going to do that. And then he asks you for a password. We can go back to the pull requests, and it's going to now enforce it. Well, it's not going to enforce it. It says, as an administrator, you may still merge this pull requests. So I can ignore that rule because I'm boss, but I could have kind of removed my from the part. Okay. Let's go back. Let's go into source awesome. Let's go to content. Let's fix the error here. So first of all, we can just do like this. And now if I run the tests, it passes. So commit all message fixed test. Push. So I'm pushing the changes upstream to the server, going back, and then that triggers automatically, which is a really nice thing. If I now try to check out master and push anything to master because I protected that branch, I'm not allowed to. Git will actually say, no, you're not allowed to push against master directly. You have to go through pull requests. Look. Hey. Well, actually right now, I'm going to do a little bit of a change here. I set it up to do it. I require code review. Somebody has to approve it for me, which is not really nice. For this example. So I'm not going to require pull review, but I am going to really kind of include myself as an administrator just to kind of see how this works. So when I go in here, now it's loud and now it's green. So now I'm allowed to kind of push these things, because now I'm not requiring code review, but I am requiring Circle CI to pass. And you kind of see the icon next to the hashes here. It's basically just 3 statuses. Red, yellow, and green, meaning failed, working on it, as in trying to run, and green meaning pass. So I can just do this. Merge. Cool. That's part. Okay. Now let's get into the territory of code coverage. It's fairly similar. It's kind of these type of tools, and I'm jumping into myself, and then I'm adding a new repository. And it's not going to be there because it's really, really slow. I'm looking for awesome, and then you have something called yeah, you can navigate directly by just going straight to the repos. If I go awesome, ta-da, that's really nice. Is that it doesn't really need to see it. So all it just says that to use it, you have to do it from command line, and here's some tips on how to do it. So I'm going to just follow the steps so you guys can see what the hell is going on. It supports a bunch of languages, and obviously we will find Python among it. Okay, this one gives you an example how to do it. You need two tools. You need the CodeCov tool, and you need the kind of testing framework to attach CodeCov to kind of the reporting system. So when you run PyTests, it also does coverage. That's what we want to do, because you have to attach your code coverage to code being run. So we need those two tools. So if we go down to the root here and go into requirements, I'm going to add PyTest cov, and I'm going to add CodeCov. Those are the two tools that I need. Okay. This is a good way of doing it. Pip install requirements. Yeah, thank you. -r, important. Ta-da, and then installs all the tools that I need. Okay, other things that it needs to be doing is that when you run PyTest, you need a --cov to the folder that you need to do the coverage in. So we need to go into my Circle CI, because we need to run this as part of my Circle CI. And then here I say cov equals source. Then source is the root directory of where I want to do my tests. Cov equals source will then include that folder. Cool. It's not worse than that. But in addition to that, we need to send the report to the to CodeCov server, which is make CodeCov report command, and to that do that. I'm wondering if we need this. Don't remember. Okay, and does it say how to do that? So pip install CodeCov and then token in case you are in a private repository. But if you're in Travis, Circle CI, or AppWire, which is competitors for continuous integration, you can just do CodeCov, which is nice. Whoop, other way around. So CodeCov. I'm leaving that be. That should be it. And we're here. Commit, well, commit all, adding coverage. Push. I'm wondering if I'm behind on master now. Check out master, pull, could do fetch, but I like to kind of, yeah, right. So check out dev. Do I have, no, that should be done. Okay, so rebase dev on top of master. Look at it now. I pushed from origin dev on top of it. So my history is keeping nice. Linear history. This is really nice if somebody's going to look through your kind of history and see what's going on. It's not a complete mess because my history is fairly linear, and you should try to strive to kind of get to that point. Okay, we make another pull request. Now we're going to include the code coverage part. Like that. Did I remember to add all files? What files do I need to add? Well, no, actually nothing. It was all already added. So things has to be done in order, obviously, because what's going on here? Should the kind of it kicking in from dev? Something is weird. Why is oh, the test is already run. Oh, sorry. I was not fast enough to catch it being going through. This thing is really fast. I'm just used to be working on project where testing takes about think it's about, if I use the buffer, it takes about 7 minutes. If I don't, it's about 11 minutes. So we have over 500 tests. So this thing goes a lot slower than the 19 seconds this thing took to complete. So that's really nice. And it made a code coverage report. It said like, hey, code coverage report worked. And I'm sending this key towards CodeCov. And it made this nice little graphic. And if we go, well, oh God, I hate the fact that it doesn't open a new window. There we go. So that happened right in this instant. Suddenly code coverage popped up and say that, hey, we have something that's going on. And the part about a message pops up as well. It takes a little bit of time. Obviously, there is a lot of communication going on. It has to create a report. So there's some kind of spin up on that end as well. But when it gets there, it creates a report. Now, this report is not that interesting because A, there's no content in my program. I have two parts. This is the init, I think, and this is my content file. So obviously, you remember the one I showed you in the beginning with a lot of fragmentation. That's because I have a big project. Small project, it doesn't matter. And my coverage report is also very interesting because I don't have reference. Obviously, it's been only run once, and this is for this case, and this is pretty red. But we can take a look at it and kind of see what's going on here. When I know what to expect here, because hey, I added in a flaw into my code by purpose. So if we go into the awesome, and here we go, content, we get a files. Give me the files. Where is my files? Bastard. Give me my files. 75% coverage for content. And I get nothing. I might need it. Yeah, I need to do this once more because I need a reference. Yeah, sure. Okay. Merge pull requests. The problem is that you have to do it once. Check out master pull. I'm gonna make a dev2 new part of things, and then say the source awesome content. I'm gonna add awesome function just to have some content here, like that. Commit all docs, and then push upstreams. I'm creating a new branch, dev2. I'm pushing it, and now I can make another pull request. This is going to take a little bit of time as well. So typically you would make a new branch each time you do this type of thing. And typically you'll start ending up using old branches after they're being merged. Rename. So this is all the change I made. It's docs. I don't really care about content. There is no conflict because obviously, again, this thing is just so damn fast that we can't really do anything else than just wait a little bit until everything is coming in. And the problem is that time is actually out, so I'm not going to have time to talk about anything else. But let's kind of just look at the coverage report. The last little thing, if we can. There we go, code report. And here, no changes, obviously. And if we look at the compare, now we should be able to look at this thing. Here we go. And here's my flaw in the sense that I said value error, wrong format. And that line never gets run because there's no part of my test that includes that line. It runs the if test in front of it, and it runs the print statement afterward, but it doesn't include the race error. And you should really kind of cover your bases. So just to kind of finish up, let's fix that problem and do a part of PyTest, which is cool. Incorrect usage. Wish I had time for more, actually. Like that. Run it. It fails. Incorrect usage. And what you get is what you call a traceback. The traceback is really nice because you can copy it in like this. Indent it, and then delete the interior, and you create something called an ellipse. Has people seen this type of style before? Test failures. So what I'm doing here is that I'm running this code and I'm expecting it to fail. and I'm telling the doc test that, hey, I expect to trace back. There's something in between. Typically, if you're going to use this normally, you would do something like doc test and then ellipse, something like that. But for errors, for failures, you don't need to do this. This is the special syntax that tells the PyTest and doctest that this is expected failure. And if I run the code now, it passes. And that's it. We can take a look at how that works and everything like that. But my time has unfortunately run out. So thank you for listening. I hope that was informative.